This video is a demonstration of the flash management capabilities provided by Linux running on the Microsemi SmartFusion device. This demo runs on the MCraft A2F LNX EVB board included in the Linux SmartFusion evaluation kit. The design used in the A2F LNX EVB board provides 8 megabytes of NOR flash by expansion. That line of flash devices also includes 4 megabyte and 16 megabyte variants. This is an inexpensive and relatively fast memory. To give a point of reference, the 4 megabyte expansion NOR flash device can be bought at about $3 from a major distributor. In this demo, I have the board programmed with a Linux configuration that is designed to showcase the flash management capabilities provided by Linux on SmartFusion. Here's a real-time view of the bootstrap sequence as shown on the board serial console. Linux for SmartFusion provides standard flash management capabilities found in today's modern Linux. These include MTD-based access to flash devices and partitions, as well as journaled file systems such as JFFS2 specifically designed for flash memory. Let's take a look at the flash partitions created in my configuration. First, a bit of theory though. In Linux, random access persistent storage devices such as flash chips, memory sticks, SPI-based EEPROM devices, and so on are supported with memory technology devices, or MTDs. The MTD subsystem was created to provide an abstraction layer between the hardware-specific device drivers and the higher-level application. The main advantage of using MTD drivers over conventional block device drivers is that MTD drivers are designed specifically for flash-based devices, so they generally are better suited for sector-based erases, reads, and writes. The Linux MTD subsystem includes the following important capabilities: MTD partitions allowing the viewing of single physical device as a user-configurable set of logical devices, each dedicated to its own need from the application standpoint. 2. Support for concatenating several physical devices into a single logical MTD device. And 3. Character and block device interfaces to MTD devices and partitions providing for raw access to flash as well as the ability to mount file systems on an MTD device or partition. With this background in mind, in my configuration I have partitioned the 8 megabytes of NOR flash into 3 partitions. The first partition is 128 kilobytes in size and is allocated to the U-boot environment variables. This area is maintained by U-boot, but conceptually the U-boot environment can be read and updated by Linux as well, allowing modification of the boot sequence from a running device as the application deems appropriate. The second partition is 2,944 kilobytes in size and is used as storage for a Linux bootable image. The default U-boot configuration auto-boots Linux from an image stored in that partition. Finally, the third partition is 5 megabytes in size and is dedicated to a JFFS2 file system used by Linux applications as storage for persistent directories and files. Let's create a JFFS2 file system in the third partition and store some persistent files in it. Unless you already have a JFFS2 file system created in your flash device or partition, the first step is to erase the flash in the corresponding flash partition and format it as a JFFS2 file system. The erase and formatting operations are going to take a bit of time, so while that's happening, let's say some more words about JFFS2. JFFS2 is a Linux file system specifically designed for uses with flash memory. It supports both NOR and NAND flash devices. Talking specifically about NOR flash, this type of flash memory must be erased before it can be written to. An erase operation is performed on a per sector basis. A typical sector would be 64 kilobytes in size or more, and this takes a substantial amount of time to complete compared to the reading data from the same region. As an additional complication, a flash sector can only be erased a limited number of times before it becomes worn out. JFFS2 ensures wear leveling of the flash memory, which essentially means that the file system architecture distributes, erase, and writes operations evenly across the available flash sector. Also, JFFS2 supports optional compression of data stored in flash, supporting several compression algorithms. Okay, so now we have a clean JFFS2 file system formatted in the third partition of our NOR flash device. Let's mount it on a directory. As expected, the file system is empty at this point. Let's now copy the BusyBox binary to the flash file system. Okay, the copy has completed, so at this point, JFS2 being in a regular file system, we can run BusyBox from that JFS2 partition. As another test, let's edit a new file in the JFS2 file system with the VI editor. We can use the df command to check the JFS2 file system space usage. As you can see, so far we have used up about 9% of the flash space, so we have plenty of space left to store more persistent data. Now let's check that the data stored in the JFS2 is actually persistent. Let's unmount the JFS2 file system and reboot the system. The system has come back up, so let's mount the JFS2 file system again and confirm that the persistent files have survived the reboot. Moving along, as I explained previously, a typical Linux SmartFusion bootstrap sequence auto-boots a Linux image from a flash region that we have mapped as the second partition in our Linux configuration. Let's go ahead and upgrade the bootable Linux image in a flash from a file that we've pulled from a mounted NFS file system. To accomplish this, what we first do is mount a directory from a development host over NFS and copy the bootable Linux image we want to install onto the target to a second partition in flash. The copy operation is going to take a bit of time since flash erase and write operations are relatively slow. Okay, the copy is completed, so let's go ahead and reboot the target and allow it to auto-boot from flash. As you can see, SmartFusion has booted from the just installed Linux image. This demo has shown a few things that are possible to do with NOR Flash from Linux running on SmartFusion. As I've mentioned earlier, the Linux kernel has memory technology drivers for flash types other than NOR Flash. For instance, we have a demo that allows showing essentially the same kind of things for an EEPROM-based flash file system connected to the SmartFusion over SPI. It is possible to split an EEPROM flash into several partitions and then mount a partition as a JFS2 file system or access it as a raw array of data. The MTD drivers are of course different for the NOR flash and the SPI connected EEPROM flash. However, from the user perspective, they can be accessed using the same POSIX interfaces and Linux utilities.